Good morning. My name is Vel Murugan. I am assistant professor in mechanical department of Panimalar Institute of Technology, Chennai. So today I am going to take a lecture on how to create a part programming for CNC turning center and CNC milling machine. Today, a lot of manufacturing industries are preferring to use CNC machine compared to the conventional machine. There are a lot of type of CNC machine, CNC milling machine, CNC lathe, CNC grinding machines. So basically, CNC machine is a short form of computer numerical control. It is an automatic machine. Uh, by means of feeding the program called NC part program uh, to the machine, it will work automatically. So by means of feeding the program into the machine, we can create the required profile on the workpiece automatically. So as it is automatic, the part manufactured from the CNC machine is having a perfect dimension. So we can manufacture precise component in CNC machine. So by means of it is mainly used for mass production. So we can store the program into the CNC machine. So whenever we need that program, we can call and run it. And by means of the CNC machine, the human intervention is less, and we can manufacture complex shaped component by means of the CNC machine ECD, and it will, as it is automatic, the production time also is less. So these are all some of the advantages of the CNC machine. So because of these advantages, a lot of manufacturing industries prefer to use CNC machine for manufacturing their products. So now we are going to see how to create a part program for manufacturing a particular component. So what are the procedure for creating the part program, that we are going to see now. So before seeing the part program, so we have to know some of the basic things to create a part program. Let us see about that. To create a part program, first we need to know what are the access convention used in a CNC machine. So just now we have told there are a lot of type of CNC machine. So in today's lecture, we are going to see how to create a part program for CNC turning center and the CNC milling machine. So first, let us see what are the axes which are used in CNC turning center. So in CNC turning center, there are basically two axes used. One is x-axis, another one is z-axis. So x-axis is a axis which is perpendicular to the workpiece axis, which is used to give depth of cut and cross feed. And z-axis is parallel to the workpiece axis, which is used to move the cutting tool in a linear path. So these are the two axes which are used in a CNC turning center. So next the axis next we will see the axis which are used in a CNC milling machine. So usually there are three axes which are used in a CNC milling machine. They are x, y, and z axis. So x and y axis are for table movement of the CNC milling machine, and z axis is for the spindle movement of the CNC milling machine. So these are all the axes which are used in a CNC turning center and CNC milling machine. So to create a part program, the knowledge about the axis is necessary. And next we are going to see what do you mean by 0 point. So you have to know about what do you mean by 0 point in a CNC machine. So usually there are two types of 0 point in a CNC machine. One is workpiece 0 point, another one is machine 0 point. Now we will see what do you mean by workpiece 0 point. So so to create a CNC part program, we have to know the position of the cutting tool. So we have to indicate where the cutting tool position is. So for indicating the position of the cutting tool, we need some reference point that is called as a 0 point. So based on that 0 point, the program will be created the program will be created for a CNC machine. So to machine a particular workpiece, the cutting tool should be moved to various position. The position of the cutting tool should be measured with respect to some 0 point. So that is called as a workpiece 0 point. So it is usually fixed by the programmer wherever he want. So based on that, the portion of the various portion of the cutting tool is mentioned in a CNC program. Next one is machine 0 point. So machine 0 point is also called as a reference point. It is fixed by the manufacturer. For a particular type of machine. It is usually far away from the workpiece. So it is fixed. It cannot be changed. That is called as a machine 0 point. Next, to create a CNC program, we need to know what are G codes and M codes, because CNC program consists of G codes and M codes. Now let us see what is meant by G codes and what is meant by M codes. So G codes stands for preparatory codes, which is used to prepare the cutting tool to move to various position. So for giving the various position of the tool position, these G codes will be used. Next one is M codes. M codes stands for miscellaneous codes, which is mainly used for controlling the various accessories of the machine. For example, these codes will be used to control the coolant motor, spindle motor, turret head in case of CNC turning center, and a tool magazine in case of CNC milling machine. So for controlling these type of accessories of the machine, these codes will be used. Next we will see what are the basic G codes and M codes for creating a CNC part program. So first one is G00. So G00 means rapid interpolation. So this code will be generally used to move the tool at a fast feed rate. Generally this code will be used when no machining takes place. For example, if you want to move the tool from a reference point to the point which is nearer to the workpiece, this code will be used, because from the reference point to the point nearer to the workpiece, there will be no machining taking place. So if there is no machining taking place, we can move the tool at a fast rate. So to move the tool at a fast rate, this code can be used. So if you use other codes, for example, if you use G01 code in idle stroke, it will increase the production time. To save the production time, the tool can be moved at a fast rate. So in that place, we can use the G00 code. So this is the syntax for G00 code. So basically G00 code will be followed by the axis position. So we have to give the G00 code. After that, we have to mention the tool position. So by means of giving this, the tool can be moved to the required position at a fast feed rate. So next we are going to see the G01 code. G01 code means the linear interpolation. It is used to move the tool in a linear path. So it can be either horizontal direction or vertical direction or inclined direction. So for that purpose, for moving the tool in a linear path, this code will be used. So this is the syntax for this code. So this G01 code will be followed by the axis position, and so after the axis position we have to give the feed rate. That means here the tool will be moving at a given feed rate, so we have to mention the feed rate. If we give the feed rate, based on that feed rate the tool will move when we use the G01 code. So here we have to mention with the axis position feed rate. Okay. Next one is G02 and G03. So if you want to move the tool at a circular path, this circular path we can use this type of code, that is G02 and G03. So G02 means the circular interpolation in a clockwise, and G03 means circular interpolation in counterclockwise. So this is a syntax for G02 and G03. That means the G02 or G03 will be followed by the axis position. So after that we have to give feed rate and radius. We have to give the radius value here because it is a circular interpolation, that is the tool are going to be moved in a circular direction. Okay. For example, this is a two position 1 and 2. So if you want to move the tool from 1.1 to 0.2, we have to use the G03 code because the path from the 0.1 to 0.2 is in a counterclockwise direction. So we have to use G03 for creating this type of circular profile. And same if you want to move the if you want to move the tool from 0.1 to 0.2, so the direction of the tool from 0.1 to 0.2 is in a clockwise direction. So in this case we have to use a G02 code for creating this type of circular profile. Next we are going to see G28. G28 means go to reference point, that is go to reference point. Just now I have told reference point means just now I have told there are two 0 point in a CNC machine. One is machine 0 point, another one is workpiece 0 point. So the machine 0 point also called as a reference point. So G28 will be used to instruct the tool to go to the reference point. So this is the syntax for G28. So G28 should be followed by the axis portion, that is U 0.0 and W 0.0. Here when we use the G28 we have to use U and W. U is the axis which is parallel to the x-axis, and W is the axis which is parallel to the y-axis. So when we give U 0.0 and W 0.0, when we use W 0.0, the tool will be instructed to go to the reference point. So after the machining operation is over, the tool will be generally instructed to go to the reference point. And when we change the tool from the one tool that we are using to another tool, in that case also we have to change the tool after the tool is gone to the reference point. So in that condition we have to use the G28 code. Next one is G21. So in the CNC program we are going to give the various axis portion. The portion of the axis may be in terms of metric units or maybe in terms of inches. So if you want to give all the values in terms of metric units, that is mm, we have to use G21 code. If you want to use all the units in terms of inches, we have to use the G20 code. So next one is G90 and G91. G90 means absolute programming and G91 means incremental programming. We will see what is meant by absolute programming and incremental programming in the later slides. So next one is G98. G98 means feet per minute. G99 means feet per revolution. That means what do you mean by feed? So feed is a movement of the cutting tool per revolution of the workpiece in case of lathe, and it is defined as it is defined as the movement of the cutting tool into the workpiece per rotation of the tool in case of milling machine. So it can be either in terms of feet per minute or either in terms of feet per revolution. If we want to give the feed in terms of feet per minute, we have to use a G98 code. If we want to give the feed rate in terms of in terms of per evaluation, we have to use G99 code. Okay, these are all the these are all some of the basic G codes used to create a part program in a CNC machine. Okay. Next one is next we will go to the M codes. So these are all some of the M codes which will be used, some of the basic M codes which will be used in a CNC machine for creating a part program. So first one is M07 and M08. Both the codes will be used to switch on the coolant motor. In some of the machine there will be two coolant motors. So for switch on one coolant motor, M07 may be used. For switch on another coolant motor, M08 is used. So basically M07 and M08 is used to switch on the coolant motor, and M09 will be used to switch off the coolant motor. And next one is M03 and M04. These code will be used to switch on the spindle motor in a clockwise or anti-clockwise. If you want to switch on the spindle motor in a clockwise direction, we can use M03. If you want to switch on the coolant motor in a counterclockwise direction, we can use M04. And M05 will be used to switch off the spindle motor. And M30 is a code which is usually used at the end of the program. So it means the program stop and return. That is, the program will be stopped and return to its initial point. That is the meaning of this code. That is M30. Next, just now I got told G90 and G91. G90 means absolute programming and G91 means incremental programming. So now we are going to see what is meant by absolute dimensioning and incremental dimensioning. So the part programming for a CNC machine can be done in two ways. One is absolute programming and another one is incremental dimensioning. So now we will see what you mean by absolute dimensioning, and next we will see what you mean by incremental dimensioning. So in absolute dimensioning, all the portion of the cutting tool will be measured from the same 0 point. That is, here the 0 point is fixed, it will not be changed. So all the portion of the cutting tool will be measured from this 0 point. This is called as if you create a part program by means of this method, that is, if you create a CNC program by means of indicating the portion of the tool with respect to the same reference point, that is called as absolute dimensioning method. Okay, so the G90 code will be used for this. If you want to, so for absolute dimensioning, the G90 code will be used. Next, for example, this is one profile. For example, so this is the portion number 1, and this is the tool portion number 2, and this is the tool portion number 3, and point number A is the 0 point. So so if you say the portion of the tool, that is 1 and 2 and 3 by means of the absolute programming, these are the tool portion. So point number 1, that is x-axis distance is 10 and y-axis distance is 5, and point number 2, the x-axis distance is 20 and y-axis distance is 10, and point number 3, the x-axis distance is 30 and y-axis distance is 15. So if you look at this, all the points are measured from the same 0 point, that is A. So next we are going to see the incremental dimensioning. So in incremental dimensioning, the 0 point for the next portion of the tool will be the end point of the preceding operation. So each portion of the tool will be measured from the end point of the preceding operation. That is called as a incremental dimensioning. G91 code is used for incremental dimensioning. Now let us see one profile. So for example, I am taking this profile. This is the various tool portion 1, 2, 3. So previously we have seen how the various portion of the tool is measured by means of the absolute dimensioning. In the same way, if you want to indicate the portion of the tool portion by means of the incremental dimensioning, so now let us see. So for the portion of the point 1 is 10,5. The portion of the point number 2. The portion of the point number 2 is also 10,5, because for point number 2, the 0 point for point number 2 is the is the point number 1, that is the 0 point for point number 2 is the end point of the preceding operation. This is the point number 1 is the end point of the preceding operation, the point number 1. So the point number 1 is the 0 point for the point number 2. So the position of the tool is same, the 10,5, and this is the position of the point number 3. The 0 point for point number 3 is point number 2. So the position of the point number 3 is 10,5 as per the incremental dimension. Okay. Next we are going to see what do you mean by offset. It's very important terms, which very important term which is used in a CNC machine. So so after creating the program by means of setting 0 point on the workpiece, so after that the workpiece should be set in the machine. So after the workpiece is set, we have to set we have to tell to the machine where the 0 point is. Okay. So the process of taking 0 point of the workpiece is called as a offset. So it is set by the programmer. So so as per the 0 point of the program, we have to set the 0 point in a workpiece. So after taking 0 point for the workpiece, it is stored in a particular memory location in a CNC machine. So for each workpiece we have to take the offset. So after offset means the process of taking a 0 point on the workpiece. So after the 0 point is taken on the workpiece, it is stored in a particular memory location. So whenever we need that, we can call it. Okay. So after the, so offset is very important term. So after the if he does not take the offset, the tool will not move in a defined path. So it's necessary to take the offset. It is necessary to mention the 0 point on the workpiece. Okay. Next, so these are some of the basic things which are needed to create a part program. Next, we will see how to create a simple program for the profile zone in a CNC turning center. So first one is O1234. O1234 means it's a program number. Usually the program number in a CNC machine is mentioned by a O, which are followed by a 4-digit numerical letter. So after that, after that G28 and U0.0 and G28W0.0. Just now we have seen what do you mean by G28. G28 means go to reference point. So before starting the program, so wherever the tool position is, it should be instructed to go to the reference point first. So after it is inserted to the reference point only, we have to write a program further. So first we have to start with the G28. So G28 U0.0 and G28 W0.0. The tool will be instructed to go to the reference point. So that is the tool have gone to the reference point. So after that G21, G90 and G99. G21 means all the dimensions that we are going to give will be taken in terms of metric units, that is in mm. G90 means we are going to create a program by means of the absolute method, so that's why I have used a G90. And G99 means I am going to give a feed rate in terms of mm per revolution. So that is why I have used G99. So these are the codes which have to be mentioned previously. Then only all the values that we are going to give will be taken in terms of mm, and the program will be in terms of absolute programming method, and feed will be in terms of feed per revolution. So these are the codes which have to be given previously. Next one is M06 T01 not 1. So the M06 means tool change. That is I am going to use the tool number 1. The first 2 digit indicates the tool number, and the second 2 digit indicate the offset number. So the first T01 not 1 means, so I am going to change a tool. I am going to change the tool number 1, and I am going to use the offset number 1. So after that, so now the tool is changed. Next one is we have to switch on the spindle motor. So I am going to switch on the spindle motor in a clockwise direction. So I have used M03. So M03 S1000 means the spindle will be switched on in a clockwise direction at a speed of 1000 rpm. Next one is M07. M07 means the coolant motor on. So before doing the operation, the coolant should be on. Then only the heat between the workpiece and the tool will be eliminated, so that tool life will be more. So before doing the operation, we have to switch on the coolant motor. That's why I have used this code here, M07. So now we are going to start our program. So before we are going to start a machining operation. Before starting the machining operation, the tool should be brought back. The tool should be brought to the point which is nearer to the workpiece. So this is the workpiece dimension. The workpiece raw metal dimension will be 25 mm diameter, and it is having a length of 45 mm. This is the raw material. That raw material should be converted as a step turned, converted as a step soft like this. So now the tool is in a reference point. That is, initially it was in a reference point. Now the tool should be brought to the point which is nearer to the workpiece. So X26. X26 and Z2. So I have taken a point which is nearer to the workpiece as X26 and Z2. Here X is a axis which is just now I have previously I have told X is a in a CNC turning center, X is a axis which are perpendicular to the workpiece axis. This is workpiece axis. So usually it is used to give a depth of cut. So always we have to give a diameter in a X value. So always we have to give the diameter value in X position. Next we have to give the Z value. Z is the axis which is parallel to the workpiece axis. So I have set a 0 point here. So after setting the workpiece, the offset should be taken. These are the details I have just now told. So for this operation, I have taken a 0 point here. I have taken an offset here. This is a X 0 point and Y 0 point. So now my task is to bring the tool to the point which is nearer to the workpiece. So this is the point which is nearer to the workpiece, that is X26 and Z2. Next I am going to do the operation on the workpiece. So for that, first the tool should be turned to a diameter of 25 mm up to the length of 45. So it is a Z0 point. So if you move it is the Z0 point, and this is the X0 point. This is the X plus. This is the X plus direction. And if you move if you move from here to here, this is the X minus portion. If you move from here to here, this is a Z minus direction. If you move from here to here, this is a Z plus direction. So based on that, we have to use the X positive and Z. Based on that, we have to. This is the axis convention, the CNC turning center. Based on that, we have to write a program. So first we have to G01 means it's a linear interpolation. So now the tool portion is X26. So now we have to turn the workpiece to a diameter of 25 mm up to a length of 45 mm length. So I have taken Z25 X25. So for that I have given a feed rate as 1.5 mm per revolution. So after that, the tool should be moved up to a length of 45 mm. That's why I have used Z minus 45 here. And next, so now the tool portion is here. So now the tool is turned to a diameter of 25. So after that, the tool is moved a little bit over the workpiece, that is X26. After that, the tool should be brought back to the initial point, that is Z2. So next we have to reduce the diameter of 20. So I have used the X20. So after that, the tool should be moved up to a length of Z minus 25. So I have used Z minus 25 here. So now the tool portion is here. So after that, the tool is moved to the X26 portion, and it is again moved to the initial point. So like this we have to do the program. And next the tool is moved to the X10 portion. So after that, it is moved to the Z minus it is moved up to a length of 10 mm. So after that it is moved in this direction and it is brought back to the initial point. So like this way we have to create a CNC program, CNC turning program. So after the operation is over, the tool should be brought back to the reference point. So I have used the code G28U0.0 and G28W0.0. So after it is gone to the reference point, the spindle should be switched off. So I have used a code M05. So after that the coolant button switched off. So I have used M09. So at the end of the program we have to use the M30 program, M30. So M30 means program stop and return to the initial point. So these are the basic procedure to create a CNC part program for a CNC turning center. Next we will see one simple program for a CNC milling machine. Okay. So for this is the finished profile. So you are given a rectangular block. So the rectangular block, on the rectangular block we have to do the end milling operation like this. We have to create a slot like this. This is the operation that we are given. So for creating a slot like this, we are going to create a part program. Okay. So in a CNC milling machine, usually this is 0 point. I have already told, in a CNC milling machine there are 3 axes. XY axis is for a table movement and Z axis is for a spindle movement. So this is the X positive direction and this is the X negative direction. This is the Y positive direction, this is the Y negative direction, and this is the Z plus and this is the Z minus direction. So usually the lower left corner will be taken as a 0 point as far as the CNC milling machine is concerned. So initially, so we will start a program now. So first one is O1234. O1234. O will be followed by a 4-digit numerical enter. That is a program number. So this is a program number. So it will be stored in a particular memory location. Whenever we name the program, just by means of giving this address, we can just by means of giving this address, we can see the program and we can do the operation again. There is no need for us to create a part program again and again. So once the part program is created and it is stored in a particular memory location, we just need to call them. So whenever we need that, we can use it. That's so next one is G28, G91 is at 0.0. So so in the CNC milling machine, if we give like this, it is it means the tool will be instructed to go to the reference point. So in the CNC milling machine, G28 should be followed by a G91 and Z 0.0. So Z 0.0, if it means the tool will go to the Z reference point. If we give like this, the tool will go to the XY reference point. So after that, as seen previously, we have to use G21. So all of you know what do you mean by G21. G21 means all the dimension are in mm. So G90 means absolute method, G99 means the feet per revolution, and G54 means it's a offset, that is the offset address. So for this program we have used this offset. Okay. So next one is M06 T01. So I am going to use a tool number 1. That's why I have changed the tool number 1. So for changing the tool, I have used a M06. Next I have switched on the spindle motor. So in a clockwise direction, that's why I have used a M03 S1500. That is the tool will be rotated at a speed of 1500 rpm, and M07 means coolant motor on. So next thing is the tool. The tool is now is in a reference point. So now we have to start the operation. So before starting the operation, the tool should bring to the point which is nearer to the workpiece. So I have to start a program from this point. So so the tool should be brought to this point. So this point is X25 and Y25. Okay, this workpiece dimension is 100 and 100. And this is 25 and this is 25. So I have to bring the tool to this point. In this point, the X value and Y value is 25. So G00 and X25 and Y25. and Z00 is at 2.0. We should not give Z 0.0 because if you touch the workpiece, that point is at 0, and if you go below that, that is set minus, and if you go above that, that is set plus. So when we use the G00 code, the tool will be moved at a fast rate. So if you give the G00, it will suddenly come to this point. So the tool will be damaged. To avoid that, always the Z portion it should be a little bit more. That is Z the little bit more. That's why I have used Z 2.0. Next one is G01. So I am going to move that to. So now I am going to give a depth of cut. So now the tool portion is set 2.0. So if you touch the workpiece, that is set 0.0. If you go below that, that is set. If you go below that, that is minus set value. So I have taken a depth of cut of 2 mm. So that's why I have used G01 Z minus 2. That means the tool will get inserted into a depth of 2 mm at a feed rate of 1.5. Okay. So next one is the tool should be moved in a linear direction. So to move the tool in a linear direction, we have to use the G01 code. G01 code is was previously used. So again, once G01 code is used, the next line also, if you want a G01 code, it doesn't need to write G01 code, because previously so G01 code will be active once it was replaced by some other code. So again and again, we doesn't need to give G01 code. So that's why I have not used G01 code here. So next portion is this portion. This portion is X25 Y75. So I have used it here. So tool from here to the tool will be moved from here to here. Now the tool should be moved from here to here. So that is also an area interpolation. So no need to give G01. So this point is X65 and Y75. That's why I have used it here. Now we have to move the tool from here to here. This is a circular interpolation. So this is circular interpolation. So this is a counterclockwise direction. So if you move the tool from here to here, this is a counterclockwise direction. So I have used a G03. So this point is X75 and Y65 and R10 and F1.0. So if F1.0 means feed rate, R means radius. Next, the tool should be moved from this point to this point. This point to this point. This point is X75 and Y35. And feed rate is F1.5. That's why I have used this line. Next, the tool should be moved from this point to this point. Again, this is a circular interpolation. Here the tool will be moved in a clockwise direction. So I have used G02 code. So G0 code, this point is X65, Y25 and radius 10, and the feed rate is 1.0. Next, the tool will be move to this point, this end point. So the end point is the same point, the end point, that is X25, Y25 and F1.5. So after that, the tool have to be taken outside. So that so I have used Z2. If you give Z2, the tool which was got inserted into the workpiece will be coming out to the workpiece to a length of 2 mm. So after that, the tool should be brought back to the reference point, that is G28. G91 is at 0.0. G28, G91 is at 0.0 0. So after that, the spindle should be switched off M05. After that, the coolant motor should be switched off M09. After that, the program, at the end of the program should be stopped and returned to the initial point. That's why I have used a M30. So these are the procedure for creating a simple program. So by means of this basic knowledge, we can create a part program for the complex profile in a CNC machine. Thank you.